Good morning, students. In today's class, we will learn about a projectile motion, which is a motion in a plane or on a plane. Now, what is a projectile? A projectile is any object which is projected into space or air such that it moves under the effect of gravity alone. So an example of a projectile may be a football which is kicked in the air, a cricket ball which is thrown in the air, then the javelin throw which is there in the athletic sports, and shot put, discus throw. These are all the examples of projectile motion, or any object you could say which is thrown into air and is under the influence or the effect of gravity alone. So here we will consider an object which is on the ground, which is represented by this x-axis, and this object is on the ground. It's being thrown into the air, or into space, with a velocity u. Then this object which is being thrown into space, this will actually travel in a parabolic path. So your object which is at this position, if it is thrown in this direction, will travel in this path, and we'll have to show that this path is a parabolic path. So here your object, starting from this position O, I can draw another axis which is the y-axis. So we have the x-axis and the y-axis. So this is the xy plane, and this projectile is moving in this xy plane. That's why this is known as a motion in a plane. So here your object of any mass from this origin O being thrown into space with initial velocity u. Now this u is velocity is a vector quantity. So we'll have to resolve this vector into two components. One is along the x-axis and another one is along the y-axis. And we have learned about resolution of vectors. So here we let this angle to be theta, and the component of this u along the x-axis is given by this ux, and the component of u along the y-axis is given by uy. So this ux is along the x-axis and uy is a vertical component along the y-axis. And here your ux, this will be equal to u cos theta, and uy, this will be equal to u sin theta. This we have learned in resolution of vectors. So we have ux equal to u cos theta and uy is equal to u sin theta. So we are going to study this motion in a plane into two components. Okay, we'll divide them into two components. One is along the x-axis, motion along the x-axis, and one is motion along the y-axis. So motion along vertical axis, and motion along the horizontal axis. And first we'll have to find the equation of trajectory. So to find the equation of trajectory, we'll have to make use of one of the equations of motion. We have three equations of motion. We are going to make use of one of those equation. So here we are going to divide the motion, projectile motion, one along the horizontal direction. So motion along, say, the x-axis, which is the horizontal direction. So motion along the x-axis, we'll have to use this equation of motion. X, this is equal to ux, then t plus half axt square. So this is the motion along the x-axis, and here this ax is equal to 0, because if we have a projectile motion, if we throw anything into space, then it's under the influence of this projectile will be under the influence of gravity, and under the effect of gravity, the acceleration will be either downwards, okay, or in this case it will be deceleration. This is retardation, and this is again the acceleration. But since it is in the negative direction, this is your y. So since the acceleration is in the negative direction, it's taken as minus. And here, since it is as you go up, the velocity of the particle, of this particle, decreases. That's why we take this also as a negative acceleration. So here the acceleration is always along the y-axis and is always negative. But along the x-axis, in this direction, there is no acceleration. So here your ax, this one, will be equal to 0, because along the x-axis there is no acceleration, because this particle is under the influence of gravity. So here ax is equal to 0. And your ux, we have done it before. This is equal to u cos theta. So we have x to be equal to u cos theta t, plus half of this one will be ax is equal to 0. So half into 0 t square. So this will be equal to 0. So then we have your x to be equal to u cos theta into t. So this can be taken as equation number 1. Now we come to motion along the y-axis. So here we have the y-axis. Now in the y-axis we will have y. Here it will be y. Now remember this equation 1. So here will be y. Then here will be uy. Here will be half ay. So this is the motion along the y-axis. Okay, so the projectile motion is now being studied under motion along x-axis and motion along y-axis. Now uy also we have studied before, and this uy is equal to how much? U sine theta. So into t plus half. Now ay is the acceleration along the y-axis, and if we throw anything, any object in this direction, okay, upward direction, then this object will decrease in its velocity. Okay, as you go up, the velocity decreases or the speed decreases. Then here it will be 0. Then again, after reaching this point, it will accelerate in the negative direction. So here the velocity decreases to 0. V is equal to 0 at this point, and from this point towards this one, it increases, but in the negative direction. So the acceleration, remember acceleration is the rate of change of velocity. So here the velocity is decreasing in this direction and it's increasing in the opposite direction of the y-axis. So because it is decreasing, we take the acceleration as in this direction as minus g, and because it is increasing in the negative direction, from here to here it's decreasing or increasing in the negative direction, again we take that as minus g. So here AY, remember this one, is equal to minus g. G is the acceleration due to gravity. Okay, this g, small g, is acceleration due to gravity. So here your AY, this will be equal to minus g. So putting this to be minus g t square. Then we put this minus sign here. This is what you'll get. So minus half gt square. So this is the motion along the y-axis. Now you recall from equation 1 how much is x equal to. Now to find one thing, to find the equation of trajectory, we'll have to eliminate this t here, t in this term and t in this term. So here we can eliminate this t by using this one. X is equal to u cos theta t, isn't it? So here from this equation 1, this is equation 1. So from equation 1, this t will be equal to, if you bring this one here, it will be u cos theta. So here your t will be equal to x by u cos theta. So instead of t here, what I'll write? This one, x u cos theta. So I'll put this x divided by u cos theta in this equation. You'll get u sine theta. So t is how much? X divided by u cos theta. Then minus half g. Then again t is how much? X. So I'll put the square because it has a square. Then the u square cos square theta. So this is by using equation 1. Okay, we have eliminated this t. Now u cancel. Then here sine by cos is how much? Sine by cos will be equal to tan of theta. So we have tan theta x minus half. Well, I'll just write this in the neat form, g. We have 2u square cos square theta, 2u square cos square theta, then into x square. So this y is equal to tan theta x. Tan theta is a constant. X minus g divided by 2u square cos square theta, and then again this also is a constant. So here this is the equation of trajectory, and this equation is an equation of parabola. So hence the motion of a projectile, okay, is a parabolic path. Okay, the path followed by the projectile is a parabola. And how do we prove it? We just find this expression, y is equal to tan theta x minus g divided by 2u square cos square theta into x square. So this is the again equation of trajectory, which shows that if we throw any object into space, it will always follow a parabolic path.